LangGraph's interrupt mechanism enables idempotent state management by pausing execution at critical decision points while maintaining consistency through persistent checkpointing. This artifact demonstrates how to combine database operations with human-in-the-loop approval workflows using the interrupt function to create resilient, user-validated state transitions. We're about to examine a node implementation that performs an upsert operation before requesting approval, showcasing how interrupts can be strategically placed after idempotent operations to ensure safe resumption of execution. The code reveals how the interrupt payload surfaces approval requests, while the graph state remains persistently stored for later resumption.
Def notice state. Hash good, using upsert operation which is idempotent. Hash running this multiple times will have the same result. db upsert user. User ID equals state user ID. Status equals pending approval. Approved equals interrupt approve this change. Return approved.
This code demonstrates a critical pattern for maintaining consistency in workflows that require human approval, combining idempotent database operations with interrupt-based approval flows. The node function first performs an upsert operation on a user record, setting their status to pending approval. This upsert is deliberately idempotent. Running it multiple times produces the same result, which is essential because the node will re-execute from the start when resumed after an interrupt. The interrupt itself pauses execution to request human approval, with the interrupt function returning the approval decision when execution resumes. This pattern ensures that even if the workflow is paused and restarted multiple times, the database state remains consistent. The upsert operation's idempotency prevents duplicate records or inconsistent states that could occur if non-idempotent operations were used before the interrupt point. This approach is particularly valuable in production systems where workflows may be long-running or require human intervention. By placing the interrupt after idempotent operations, you maintain data consistency while still enabling human-in-the-loop approval processes. The trade-off is that all operations before the interrupt must be designed to handle multiple executions safely, which may require additional consideration in your data access layer design. Let's break it down.
Def notice state.
Defines a function named node that takes a single parameter, state, with type annotation state. The function signature indicates this is a node processor in a stateful workflow, expecting the current state object as input.
Hash good, using upsert operation which is idempotent. Hash running this multiple times will have the same result. db upsert user.
Calls the upsert user method on the database object to perform an idempotent operation that either inserts a new user or updates an existing one. The comment indicates this operation can be safely executed multiple times without changing the outcome, ensuring consistent state regardless of how many times it's called.
User ID equals state user ID.
Extracts the value associated with the key userid from the state dictionary and assigns it to the parameter userid. This passes the user identifier from the current state to whatever function or method is being called, ensuring context continuity.
Status equals pending approval.
Assigns the string value pending approval to a variable named status. This creates a simple string variable that can be used to track or represent an approval workflow state.
Approved equals interrupt approve this change.
Calls the interrupt function with the string approve this change as its argument and assigns the returned value to the variable approved. This line appears to be prompting for user confirmation of some change, with the results stored in approved for later use.
Return approved, approved.
Returns a dictionary with a single key, approved, whose value is the current value of the variable, approved. The key insight here is how LangGraph's interrupt mechanism enables safe human-in-the-loop workflows by strategically placing pauses after idempotent operations. The upsert operation ensures the database state remains consistent regardless of how many times the node re-executes after an interrupt, while the interrupt itself creates a clean decision point for human approval. This pattern guarantees that even if the workflow pauses and resumes multiple times, the system maintains data integrity through idempotent operations before the interrupt point. The trade-off is that all pre-interrupt operations must be designed for safe re-execution, which may require careful consideration in your data access layer design.
The interrupt demands approval. Yet the state marches blindly into paths it never selected.